Hello friends, welcome to Flexible Packaging Part 17.2. This part is about operational efficiency. In Part 17.1, we discussed the most critical problem faced by the flexible packaging manufacturers in India today is getting the desired price for quality products while dealing with high competition and rising input cost. We are launching a dedicated solution series to address this most critical problem faced by flexible packaging manufacturers in India. This series is structured as multiple short actionable videos, part 17.1, part 17.2, up to 17.12 and beyond. Each part explores a specific strategy to improve profitability, operational efficiency, pricing power, and customer retention. So, stay tuned, subscribe, and follow the full journey towards better margins and sustainable growth. Friends, let's start part 17.2. Operational efficiency is critical for improving margins, reducing cost per unit, and delivering consistent quality in the competitive flexible packaging market. Now, let's discuss how to improve machine utilization. Reduce downtime with preventive maintenance. Here the goal is prevent sudden breakdowns by scheduling routine checkups. As an example, a flexible packaging unit in Surat implemented a preventive maintenance schedule with visual checklist and weekly audits. It reduced unscheduled downtime by 28% in 6 months. As for example, for laminator machine, the downtime before the preventive maintenance, it was 16 hours per month, then it reduced to 8 hours per month. In the same way, for rotogravure press or CI press, downtime reduced from 22 hours to 14 hours. So, a regular preventive maintenance is must for better machine utilization. Here I suggest watch my video about maintenance manual. You can scan the QR code and get the link to watch the video, or I have also given the link in the description. The second thing you have to do to improve machine utilization is to implement OEE tracking. OEE means overall equipment effectiveness. Its formula is OEE equal to availability into performance into quality. So you have to track this OEE. Let's take example. Availability is equal to 90%, performance is equal to 95%, and quality is 98%. That means OEE is 83.61%. Industry benchmark is OE should be more than 85%. So please track your OE on daily basis and find out whether it is more than 85% or not. You may like to understand what is OEE. So let's discuss more about OEE. In the OEE, overall equipment effectiveness formula, the three key components availability, performance and quality each represent a distinct area of equipment efficiency, and here is the breakdown. Let's understand what is availability. The percentage of scheduled production time during which the machine is actually running. Its formula is availability is equal to operating time divided by plant production time, where operating time is equal to plant production time minus downtime. Downtime includes breakdowns, setup, maintenance, etc. Here is an example. Plant production time is 8 hours, that is 480 minutes. Downtime due to cleaning, setup is 40 minutes. So availability is 480 minus 40 divided by 480, that is 91.7%. Now let's understand what is performance. How efficiently the machine runs compared to its maximum speed or ideal cycle time. That's the performance. Its formula is, the simplified formula is performance is equal to actual output rate divided by maximum possible output rate. As an example, the ideal speed is 100 meters per minute and actual speed is 90 meters per minute, then performance is 90%. Now let's discuss quality. The percentage of good units produced versus total units produced. Formula is quality is equal to good output divided by total output. Example, in context of flexible packaging, total meters printed 10,000, rejected meters, that is due to color variation, registration issue, etc. is 500 meters. So the good output is 9,500 meters. So quality is 9,500 divided by 10,000, that is 95%. OEE is calculated by combining these three parameters. So in this example, it is coming 78.3%. So the machine is 78.3% effective. There is a room to improve by reducing downtime, increasing speed, or reducing defects. Remember, the OEE greater than 85% is considered world class. One of the most effective way to improve machine utilization is to schedule short run jobs together. It reduces cleaning time, setup time, and ink losses. Let's discuss illustration. Let's analyze which types of jobs can be grouped together, how to do it effectively, and what gains can be expected in next few slides. Flexible packaging manufacturing is done in parts like printing, lamination, and pouching. So in this slide, we are discussing job grouping criteria for rotogravure printing. We can take criteria like same repeat length can be combined, same substrate type and GSM can be combined, same ink set family can be combined, similar design structures can be combined, same customer brands can be combined. Example and benefits are given on the screen. I am pausing a bit so you can read entire slide. In this slide, job grouping criteria are given for lamination process. In lamination, same adhesive type can be combined, same substrate combinations can be combined, same lamination width can be combined, same machine settings can be combined. The examples and benefits are there in the slide. Please go through the same. In this slide, job grouping criteria for pouching process are given. Same pouch format can be combined. Same zipper or valve features jobs can be combined. Same width and cut length can be combined. Same micron combinations can be combined. The examples and benefits are there on the screen. Here is the potential gains from smart job grouping. Average setup time can be improved by 48%. Waste during setup can be improved by 50%. Machine utilization can be improved by 13%. So this is a very good and very useful exercise. So focus on job grouping, particularly when we have small jobs. Now let's discuss implementation strategy to improve machine utilization. ERP job ticket analysis, filter by substrate, repeat, design, customer, etc. So your ERP should have this facility, and you should do job ticket analysis by filtering substrate, repeats, designs, customer, and group various jobs. Second point is pre-press coordination. Use design banks to minimize engraving variation. So your design folders should be well organized for this activity. Daily production planning board. Visualize group job clusters. Operator SOP. Document setup routines for batch jobs. Sales team coordination. Communicate group delivery windows to clients. So finally, you also have to convey to sales team, and sales team has to convey to customers about the delivery timeline. Now let's summarize. Group jobs based on printing, where grouping basis will be repeat length, substrate, ink side, etc. In lamination function, the grouping basis will be adhesive type, width, and structure. In pouching process, the grouping basis will be pouch type, size, zipper, sealing, etc. A lean manufacturing is very important tool to improve operational efficiency. Lean manufacturing is a systematic approach focused on minimizing waste, that is non-value adding activities, while maximizing productivity and customer value. Originally developed by Toyota as part of the Toyota production system, it is now widely used across industries including flexible packaging manufacturing. The core objectives of lean manufacturing are eliminate waste, improve process efficiency, deliver more value to customers, reduce cost and lead times. The term muda is a Japanese word meaning waste. There are 7 types of waste in lean manufacturing. Its short form is steam wood, because this word is easy to remember. Here T means transport. Unnecessary movement of materials has to be stopped. Example is repeated movement of printed rolls between departments. I means inventory. Excess raw material or WIP. Overstocking of adhesives or inks are to be stopped. M means motion. Extra movements by employees. Walking long distance to fetch tools should be avoided. W means waiting. Idle time due to delays. Press idle waiting for approval. O means overproduction. Producing more than needed. Printing excess rolls not yet ordered should be avoided. Another O means overprocessing, doing more work than necessary. Extra color proofing round should be avoided. D means defects, errors causing rework and scrap. Cylinder alignment issues needing reprinting should be avoided. So there are certain lean tools applied in flexible packaging like FIRE system, that is workplace organization: sort, set, sign, standardize and sustain. Another lean tool is value stream mapping, Kaizen, that is continuous improvement. You can go through some more tools on the screen. If you want to know about lean manufacturing in details, then do comment in the comment box so that I can make a video series about lean manufacturing and how it can be used for flexible packaging. So do comment. Lots of benefits of lean manufacturing like lower cost, higher quality, faster delivery, better space utilization, improved morale and ownership. Energy accounts for 8 to 12% of total production cost in many plants. So energy optimization is very important for operational efficiency. There are many techniques to reduce energy cost. Some of them are mentioned here with benefit, investment, annual saving and payback. You can go through the slide. LED lighting retrofit, VFD on motors, rooftop solars are some of the solutions. Reducing cost in the flexible packaging industry, especially in rotogravure printing, is essential for profitability without compromising quality. Here are practical and proven ways to save on ink cost. Optimize ink formulation to reduce ink cost. The strategy is use high strength inks. Higher pigment concentration means lower consumption per square meter. The impact will be 15 to 20% ink savings. Second strategy is to use toluene free or low viscosity inks, which flows better, reduces film weight and improves mileage. Impact is reduces VOCs and ink film thickness. VOCs stand for volatile organic compounds. Ink mileage improvement will help to reduce ink cost. The method is to reduce analogs or cell volume and optimize engraving in gravure printing. For solid areas, use higher cell depth. For fine details, use shallow depth. Here I suggest using good quality rotogravure cylinder from reputed companies like Afflatus Gravure and Uflex to save your ink. Use thinner ink film. Use correct blade pressure and viscosity control to avoid heavy laydown. Adjust doctor blade angle and pressure. A worn or misaligned blade waste ink through uneven laydown. Through ink recovery and reuse, you can reduce ink cost. Options are ink kitchen system and shade matching from return ink. Further details are given on the screen. Preventive maintenance of inking system can help you to reduce ink cost. Maintain proper Dr. Blade settings to avoid excessive ink transfer. Regular cleaning of cylinders and ink lines prevent buildup which causes uneven laydown. Maintain viscosity controllers, keeps ink within optimal viscosity range and prevents overuse. Job planning optimization will also help you to save ink. Group similar color jobs, reduce ink wash up and wastage between job changes. Avoid unnecessary color complexity. Use standard 7 color extended gamut printing where applicable. If you want to know more about standard 7 color extended gamut, please comment in the comment box. Training operators on best practices can also help you to reduce ink cost. Train operators for viscosity and pH management, blade setup and cylinder preparation. Automated ink management systems like auto viscosity controllers and ink dispensing systems will help you to reduce cost. Potential savings from ink cost reduction is quite considerable. As you can see, from ink formulation and selection you can save as good as 50,000 to 1 lakh rupees per month. From ink recovery and reuse you can save 75,000 to 2 lakh rupees. From operator training and SOPs you can save 25,000 to 75,000 rupees. Through automation and investment you can save 1 to 3 lakh per month post payback. Here is the key metrics to track. Machine downtime should be less than 10 hours per month per line. OEE should be more than 85%. Ink waste should be less than 4% of usage. Setup time for short run jobs should be less than 20 minutes. Energy cost per metric ton of output should be around rupees 3000 to 4500. This is just a guideline, so based on your experience and your actual cost you can make your own target and benchmark. In next part 17.3 we'll discuss about strategic pricing and customer segmentation. Do like, share, comment and subscribe. Thank you.